The title of my presentation is One of the Grandest Views in Nature, the Geology of the Great Falls, Lewis and Clark Geology of the Great Falls. And not only do I hope that this provides you with some of the Lewis and Clark science behind your visit here, but also that you'll see some of the sites that perhaps you'll have a chance to visit over the next few days. Now, before I begin, I would like to dedicate my talk to a number of individuals who are no longer with us, that extended to me great friendship and great interest in my research over these last 30 years. You know, Don Peterson and I met in 1998 when a group of friends and I showed up here at this interpretive center like a week after it opened. And we showed up completely clueless and unsure of what to do. So Don saw us milling about, he stepped up and he personally led us on an auto tour of the portage route. And he kept us spellbound all day on the trials and tribulations of the portage. And I'll never forget that act of gracious hospitality. Jerry Garrett was one of the first people to welcome me to the foundation back in 1998, and he was unfailingly encouraging in reviewing my articles for We Proceeded On. Like all of you, I enjoyed his company, his radiant warmth, and his infectious enthusiasm. And lastly, Robert Heacock and I were sort of comrades in arms when it came to discussing the dam removals on the lower Salmon River. And he was very generous with his time and sharing with me his research, because I'm in the dam removal business. And he would speak to me about the imperiled salmon species that are going extinct, and I have missed those conversations. I do wish they were all here today. I am pleased to announce that my book, entitled Scenes of Visionary Enchantment, has been published. I'm hoping to receive like 12 copies by noon today, because I've yet to see it. This book was the culmination of about 30 years of research on the Lewis and Clark Trail. And don't be frightened by geology. In fact, I do have to talk about geology later. It'll be okay. It's more than just geology. I opine on a little bit of archaeology and art history. It's a bit of a detective story as I try to find out what happened to the mineral samples and the fossil samples collected on the expedition, which took me from Philadelphia, my hometown, to Paris. And I also speak in certain instances about the ecological peril that the trail faces based on my 44 years of cleaning up hazardous waste and doing environmental restoration in my career. I will tell you, though, that the geology of Great Falls was so interesting and the journal so rich in detail that Great Falls merited its own standalone chapter in the book, the only locale to do so. So as I said, if you come to the authors event this afternoon, I might have a few, but the publisher, feeling terrible about this, is allowing me to provide a 20% discount on the price of the book if you order while you're at the conference. And so I hope to see you at 1 o'clock. And that's your sales pitch for today. I'm not going to sell you a timeshare. So the Lewis and Clark expedition, this is why we're all here. The expedition is remarkable in so many different aspects. It documented a paradise found when this continent possessed an unimaginably rich abundance and diversity of animal life. As you all know, it was the opening act of Western exploration and settlement. It was the first comprehensive accounting of a botanical garden of Eden of native plants in North America. And of course, it remains an epic adventure, an astonishing feat of endurance over 28 months, including the famed 18-mile portage here at Great Falls, and that long, dreary winter encampment at Fort Clatsop surviving on elk. I would be remiss if I did not mention the captain's geographical discoveries, which were brilliantly examined in detail by John Lillian-Zallen's book, Passage Through the Garden. And I need to recognize that the expedition journals contained a priceless record of vanished and irrevocably changed Native American cultures, superbly contextualized in historian James Ronda's Lewis and Clark among the Indians. Now, I appreciate and value all of those diverse accomplishments and discoveries. But I have asked, what about geology? Geology, particularly mineralogy, and the collection of mineral samples was an important aspect of the Lewis and Clark expedition. So this morning I'd like to discuss some of the insightful observations of the geology of Great Falls in the Lewis and Clark journals. So over the next 40 minutes, I'll briefly discuss the geology and mineralogy goals set out in Jefferson's instructions for Lewis. I'll present the essential Lewis and Clark geological observations of Great Falls, the waterfalls, the sulfur spring, and the giant springs. And I'm going to provide you with one example of the many that I have uncovered of the underappreciated scientific value of the captain's geological observations that were included in Nicholas Biddle's and Paul Allen's History of the Expedition under the command of Captains Lewis and Clark, published in 1814, which we all know as Biddle's History. So I'm thinking these guys need no introduction to this knowledge of their lives. So I'll be brief. President Thomas Jefferson's thinking in selecting 28-year-old Meriwether Lewis was that Lewis was, or would soon become, proficient in several aspects of natural history, including botany, zoology, and astronomy in the service of surveying. He also possessed, in Jefferson's words, a firmness of constitution and character, and his journals reveal an intense scientific curiosity and a keen eye for detail. As you all know, before the expedition set out from the east, Lewis chose a former Army comrade, William Clark, to be co-leader of the expedition. I could list the many things that William Clark was good at, and we would be here most of the morning. He was an expert terrestrial surveyor, an expert dead reckoning map maker. But for my purposes, we're very fortunate that he, in many instances, became the day-to-day logistic leader of the expedition, allowing Lewis to focus on scientific pursuits. And as Clay Jenkinson has noted, because of Clark, we have an adequate narrative of the expedition. And I also discuss in the book that Clark was capable of his own independent scientific discoveries, that he was no mere copyist of Lewis's discoveries. So when President Thomas Jefferson was finally ready to implement his ambitious plan of Western exploration, he authored a most remarkable set of instructions, essentially a blueprint of discovery, which we all know as the Instructions to Lewis. This document was both like a guidebook and a checklist, specifying the types of observations necessary to document the botany, ethnology, geography, meteorology, zoology, and yes, mineralogy of the expedition route, supporting Jefferson's longtime belief that science should be applied to further progress and ensure human happiness. I love these portions of the instructions the most. In the geological realm, Jefferson instructed Lewis to take note of the remains and accounts of any animals which may be deemed rare or extinct, the mineral productions of every kind, but more particularly metals, limestone, pit coal, saltpeter, salines, mineral waters, noting the temperature of the last and what such circumstances as may indicate their character. And Jefferson also mentioned the need to record volcanic appearances. You are all familiar with the 28-month, nearly 8,000-mile round-trip journey from St. Louis to the Pacific Ocean that commenced in May 1804. However, some of this route was not accessible to me in my evaluation of expedition geology, but luckily certain segments were. There was a segment in Missouri, actually two, one in Nebraska, South Dakota, and North Dakota, that were exceptionally revealing and worthwhile. Although you know that most of this route has experienced massive human-induced change, particularly flood control hydropower dams that have drowned hundreds of miles of river. Once across the Continental Divide, along the Snake and Columbia Rivers, I found it practical to work around the 8 hydroelectric dams all the way to the Pacific Ocean. But it was the expedition route approaching the Rocky Mountains throughout Montana along the Missouri River that was the most rewarding, primarily because long stretches have remained untouched by development. This morning, however, we're going to be focusing on just a 13.25-mile segment of features in Great Falls between Black Eagle Falls and the Sulphur Spring that the captains documented between June 13th, 1805, up to their departure on July 15th, 1805. So let's start with the magnificent waterfalls. We are currently sitting here in this fantastic interpretive center on the Red Star. The blue dots indicate the location of the 5 major waterfalls, only 4 of which are visible in the present day. And this morning I'm going to discuss some of the captain's observations about these waterfalls, how these waterfalls formed in relatively recent times, surprisingly, and which portions of the falls have been lost to powerhouse and dam construction. For reference, there's the location of Sulphur Spring, and there is the Giant Springs. And I'll conclude my presentation by highlighting what the captains had to say about these interesting features and the recent chemical analysis that I conducted that reveals important aspects of these features. In the course of my presentation, I will also bring forth 3 absolutely superb drawings made by William Clark, included in Clark's notebook journal called Voorhees No. 1, which is held at the Missouri Historical Society in St. Louis. These are Clark's drafts of the Great Fall of the Missouri, the draft of the Handsome Falls of the Missouri, which is actually today's Rainbow Falls, and this drawing also contains a depiction of the Crooked Falls, and lastly, the draft of the Upper Falls of the Missouri, which we know today as Black Eagles Falls. Meriwether Lewis was always reliable in giving a sense of the geography and geology of the locations of the trail they were passing through. In this case, he described the primary river features and the geomorphology of the river canyon in this way. The river is one continuous scene of rapids and cascades, and the cliffs still retain their perpendicular structure and were from 150 to 200 feet high. He also stated that the river here appears to have worn a channel in the process of time through a solid rock. Now in Montana, when Lewis commented about the process of time or the course of time, it was usually in the context of the Missouri River cutting a channel through solid rock, presumably over an unimaginably long period of time, and that was usually correct at the gates of the mountains, for example. But little did Lewis know that the river reach encompassing the Cascades, the cataracts, and the rapids at Great Falls was so young geologically, forming as late as 9,500 years ago, when impounded waters from a former glacial lake called Glacial Lake Great Falls was suddenly released. Now, this sounds incredible, doesn't it? That a river canyon could form in a time when Paleo-Americans were inhabiting this region? So I decided to seek out a modern analog of this modern canyon, and I found the near equivalent here at the Galfass Falls in Iceland, where meltwater from a glacier encountered an obstruction and took a hard right-hand left turn and excised a steep-walled canyon. Now, geologists postulate that when Glacial Lake Great Falls drained at the end of the last ice age, the rush of meltwaters encountered an obstruction, which was probably an ice dam or an ice lobe, that little blue rectangle that you see there, and cut a new Missouri River channel and abandoned the pre-glacial channel. which is now occupied in part by a very small creek called Sand Coulee Creek. Lewis then encountered the first falls of the Missouri on June 13, 1805. He said, "I saw the spray arise above the plain like a column of smoke, which soon began to make a roaring too tremendous to be mistaken for any cause short of the great falls of the Missouri." So let's have a look at where Lewis was when he made this observation. I took my position on the top of some rocks about 20 feet high. Opposite the center of the falls, this abutment of rock defends a handsome little bottom of about 3 acres, which is diversified and agreeably shaded with some cottonwood trees. Lewis was speaking, of course, of today's Ryan Island, which is much altered from when Lewis saw it, but it still retains that abutment of rock, which was, and I did measure this, 20 feet high. And that rock today that you can visit still provides a superb vantage point to view the falls. Lewis then turned his attention to the falls themselves. Now he's moving from south to north or left to right when he's writing these observations. A smooth, even sheet of water falling over a precipice of at least 80 feet. In fact, this far left portion of the falls, again, you see to the left, do have several sections where the falls plunge literally uninterrupted for the full height of the waterfall. But now Lewis is shifting his gaze again from left to right. So there's the vertical falls. And Lewis perceptively notices a difference in the fall's morphology. The height of the fall is the same as the other, meaning the vertical portion. But the irregular and somewhat projecting rocks below receives the water in its passage down and breaks it into a perfect white foam, which assumes 1,000 forms in a moment. Indeed, this section of the fall is composed of 2 different rock ledges. The lower ledge extends farther downriver, and when the falls are flowing in full, like they did for millennia, Lewis's description of a billowing white foam, which assumes 1,000 forms in a moment, really captures this enchanting scene rather nicely. Now you can better see the surviving portion of what Lewis described as projecting rocks from on high. Right there. Now, though Lewis continued his description of the Great Falls all the way up to the north bank, the construction of the Ryan Dam, and particularly its powerhouse, destroyed 1/3 of the falls complex. However, historical photographs do show that Lewis's projecting rocks formed a very nice, well-defined, curved apron. Now, there was another feature that Lewis described that is not apparent today. I was particularly intrigued by this statement. The river is divided by a large rock which rises several feet above the water and extends downward with the stream for about 20 yards. And I wondered whether this rock was this feature that was included in John James Barrelet's circa 1807 drawing of the Great Falls that Lewis personally commissioned. Now, this drawing was not in the 1840 Middle History, but it was published in an 1817 Dublin reprint. So here's that rock, that triangular rock. I was like, what could this be? So I researched all the available historical photographs of the falls, and I came across just one by a G.V. Barker that showed a triangular island that appears to me, as a geologist, as a gravel bar rather than some isolated rock. But I think Lewis observed a similar feature like this, and Barrelet applied some artistic license when he made this lithograph. Now, we all know at the close of Lewis's June 13th, 1805 journal description of Great Falls, he lamented that he did not have the pencil of Salvador Rosa or the pen of Thompson, poet James Thompson, to give the enlightened world some just idea of this truly magnificent and sublimely grand object. Well, Salvador Rosa was a 17th century Italian Baroque landscape painter, renowned both then and now for his dark, romanticized depictions of untamed nature. I had the rare privilege of closely examining Rosa's circa 1665 painting entitled Rocky Landscape of the Huntsman and Warriors of the Louvre in Paris, which included many of his signature motifs, including placing small figures, in this case a hunter and several figures in military attire, within the contents of these dangerously rugged, dramatic landscapes, and always had ominous weather. Now, surprisingly, just a 5-minute walk from the hotel from last year's meeting, the Nelson Atkins Museum in Kansas City holds another great example of Rosa's work, entitled Mercury, Argus, and Io. So whether he was depicting landscapes or his series of mythological scenes, Rosa was strongly associated with depicting precipices and great rock masses of fantastic form, cascades, torrents, desolate ruins, caves, trees dense of growth, blasted trunks, and shattered boughs. So in my book, I try to explain why Lewis invoked an absent artist and an absent poet to do what he felt he could not do in describing the scene before him. The best analogy I could give you, if you go out, is that you and I wished we had the camera of Ansel Adams to capture these scenes. That's what Lewis was doing with his illusion. Okay, so we're having a geology alert. Don't be frightened. Before I go on to discuss the other waterfalls, we have to have a geology moment to discuss how waterfalls form, because I think it will help explain to you why some waterfalls along this reach of the Missouri River are higher than others and have different morphologies. So I hope that you find this informative. Waterfalls start to form when a river flows over a hard rock layer onto a soft layer. That soft layer erodes more readily, so it forms a step in the riverbed. The cascading water creates a plunge pool while undercutting that rock layer. That undercut rock layer is like hanging in space now, so eventually it'll fracture and collapse. The fallen rocks in the plunge pool swirl around and with hydraulic action abrade that softer rock even further, and with additional hard rock lead collapses, the waterfalls retreat upriver. Importantly, you'll see it in 2 slides from now, the height of the sheer single vertical drop of a waterfall, which is called a plunge, is governed by how thick that hard rock layer is. And I'll show you an example of that in just a few moments. Moving upriver on June 14th, the following day, Lewis encountered Crooked Falls, which is a name that is retained to the present day. That's Meriwether Lewis's description. He wrote, "This pitch, which I call the Crooked Falls, occupies about 3/4 of the width of the river, commencing on the south side, extending obliquely upwards about 150 yards, then forming an acute angle, extending downwards nearly to the commencement of 4 small islands lying near the north shore." And that angle is very evident today. This erosional pattern is not unusual for the Kootenai Formation, which is the rock that underlies all of Great Falls. In fact, there's a cascade downriver of Black Eagle Falls, the former Coulter Falls, even the rapids that we saw yesterday on our Sulphur Spring hike all angle across the river. Now it's time to bring back those fantastic maps by William Clark. It's such a joy to seek out features that the captains described in their journals or only that Clark wrote on these maps. And I'll point out just 2 here. For example, look how well Clark depicted the angular geometry of Crooked Falls, again, which Lewis called an acute angle. And notice also what Clark called a sluice of water with a rapid descent, which is just slightly offset from the apex of that acute angle. As you have all experienced, one of the joys of retracing the trail is when you see firsthand something that the captains described in their journals. So let's zoom in here so we can see these two features up close. Here is the apex of Lewis's acute angle, and here is Clark's sluice of water with a rapid descent. So now that we've reviewed Great Falls and Crooked Falls, it's worth asking, why are there two different waterfall morphologies here in Great Falls? Falls that are higher and right straight across the river versus falls that are lower and have an angle. So please recall that earlier slide where I said the height of the waterfall plunge is 100% governed by the thickness of the rock layer. The Great Falls is comprised of a layer of the Kootenai Formation that is very thick. It's massive, it's more resistive, and it forms relatively high vertical cliffs. Therefore, it forms relatively high vertical plunges in waterfalls, whereas another member of the same formation is thinly bedded and contains many soft interbedded layers, so it can't form steep and high slopes. It only can form short drops that tend to retreat upstriver over long distances in an angular fashion that align with the thowweg of the river channel. So that concludes your geology lesson for today. I think I'm going to give you all an A. Upon reaching Rainbow Falls, Clark's Handsome Falls, remember, Lewis noted a cascade of about 50 feet perpendicular, stretching at right angles across the river from side to side, to a distance of at least a quarter mile, where the river pitches over a shelving rock with an edge as regular and as straight as formed by art. Well, I suppose the only advantage of seeing these falls so starved for water, the water here is being diverted into a canal for the Rainbow Dam powerhouse, is that it's pretty apparent that these falls actually do have a small apron feature on the southwest side. Thus, it is not as regular and as straight as Lewis supposed. However, I prefer this historical view of the falls in all their glory. This is how the captain saw them. Clark described this as one of the grandest views in nature and by far exceeds anything I ever saw. The Missouri falling over a shelving rock for 48 feet and 8 inches. So let's acknowledge here the fearless William Clark, who never hesitated to place himself in danger to measure the height of cliffs and waterfalls, and who, by the way, nearly fell to his death measuring the height of the Great Falls on June 17th. But according to Clark, he had a much easier time here at Rainbow Falls. I descended the cliff below this cataract with ease and measured the height of the perpendicular fall. And now in a beautifully written passage comparing the Great Falls with Rainbow Falls, Lewis reflected, "Nor could I for some time determine on which of those two great cataracts to bestow upon, on this or that which I discovered yesterday at the Great Falls. At length I determined between these two great rivals for glory that this was pleasingly beautiful, while the other was sublimely grand. But this pleasing, beautiful view of nature has also been altered by dam construction. So take a mental note of this island and this wide sweeping platform of smaller cascades. Diligently, Clark mapped these very same features on his map of Handsome Falls. So here's the island covered with cotton trees and higher than high water. And here is those stair-step rapid descent of about 5 feet to a cascade about 4 feet. So Clark found these features to be significant enough to draw. Today, however, that approximately 190 by 70 foot island that's covered with cotton trees is still visible today, but it is landlocked along the northeast shoreline, and those smaller stepwise cascades, which Clark noted, they are now high and dry and covered with vegetation. However, at least we get to see them, because one of the 5 major waterfalls witnessed by the expedition, subsequently named Coulter Falls, cannot be observed in the present day because it's drowned in the impoundment of Rainbow Dam. Historical photographs indicate, however, that it had a cascade of about 14 feet, possessing a perpendicular pitch of about 6 feet, and you'll notice that it had an angular geomorphology just like Crooked Falls, although this was rather asymmetrical. Lastly, of today's Black Eagle Falls on June 14th, Lewis concisely noted, "This cataract is not immediately perpendicular. A rock of about a third of its descent seems to protrude to a small distance and receives its water in its passage downwards and gives a curve to the water, though it falls mostly with an irregular and smooth sheet." Clark did not opt to depict the curved nature of the falls on his simplified drawing of the falls, but that's okay. He put all of his effort into the other two. Lewis, as he normally did, would always try to put everything within a context. So he's now comparing and contrasting the 5 falls that he has seen. He then ranks Black Eagle Falls like this. This fall is much the greatest I ever beheld, except for those 2 which I mentioned below, Great Falls and Rainbow Falls. It is an incomparably a greater cataract and a more noble, interesting object than the celebrated falls of Potomac and Schuylkill, etc. Ouch. Now, as a representative of the East Coast of the United States, on behalf of my hometown of Philadelphia and for Washington, D.C., I object. Had I been on the expedition, I would have gently reminded Mr. Lewis that the former falls of the Schuylkill were quite substantial before they were dammed in 1821, and the present-day falls of the Potomac are, in fact, a higher feature than Black Eagle Falls, albeit over a longer distance. But I think we can forgive Lewis for his zeal, his enthusiasm, and his sheer wonderment regarding the magnificent walls of Great Falls. Now I'd like to discuss the captain's observation of the sulfur spring. There was a brief excerpt of this in the last issue of YPO, the May 2026 issue. On June 16th, some 5¼ miles downstream of the Great Falls, William Clark reached Portage Creek, today's Bell Creek. He noted, "I walked up on the large side as high as a large creek, which falls in on the larboard side." We all know why Clark stopped at this confluence. He's scouting the portage route that would enable the expedition ultimately to bypass the waterfalls of Great Falls. Now, I believe that Clark's sighting of the sulfur spring that day was abetted by seeing a small cascade just 70 feet from the riverbank. In fact, Clark states that Portage Creek is opposite a large sulfur spring which falls over the rocks on the starboard side. Now, about 2 o'clock that same day, June 16th, Lewis also takes note of the cascade leading away from the spring. He said it discharges itself into the Missouri over a precipice of about 25 feet, forming a pretty little cataract. Now in his journal, there it is. In his journal, aside from his comments about the spring and his comments about the portage, Lewis also wrote about his concern for Sacagawea. "I found the Indian woman extremely ill and much reduced by her indisposition. This gave me some concern as well for the poor object herself, than with a lone child in her arms." Now, Lewis was cognizant of the Jefferson's instructions about recording mineral waters, but I do think his interest in the spring this time was primarily due to his concern with Sacagawea, and he's thinking about applying the supposed therapeutic benefits and virtues of the spring water to remedy her condition. Investigating the spring further, Lewis noted the water is as transparent as possible, strongly impregnated with sulfur, and I suspect iron also. Lewis ordered one of the canoes to pass and repass the river for the purposes not just of hunting, but to procure the water of the sulfur spring, the virtues of which I now resolve to try on the Indian woman. But Is there actually elemental sulfur in sulfur springs? When I began my research, I was surprised to discover that a widely available article on the Discover Lewis and Clark website unequivocally said there is no sulfur in sulfur springs. That could be a problem. When I checked on this, it turned out in the last 90 years, the Montana Bureau of Mines and Geology have sampled the spring twice. Once on July 9th, 1932, and another sample 65 years later on March 21st, 1997. Importantly, though, I determined that elemental sulfur an analytical test for sulfur had not been performed. If you don't test for a chemical compound, you can't claim that it's absent. And I see this every day in my work in environmental geology, particularly when opposing parties claim to not have contamination in the groundwater, and I come to find that they never sampled for it. So I decided to sample the spring myself to test for the presence of sulfur. I collected 2 samples, one at the spring and the other at that cascade that Lewis and Clark noted near the Missouri River, to satisfy just my curiosity about whether there's a difference in the concentration of these constituents between the spring and the cascade. You can see my sample bottles right there. Now, as I write in the book, the challenging climb out of this ravine took several attempts. Gave me several moments of apprehension and wishing that I had left a note on my car about where I was. But despite that, the 2-mile walk back, I also have a 40-pound backpack because when you collect analytical samples, you have to ice them down immediately. I gratefully got back to my car. And I was optimistic that the analytical results would reveal something important about the environmental chemistry of the spring, presence or absence. Well, you can imagine my delight several weeks later when I received this analytical report, which indicated that yes, elemental sulfur was detected at 325 milligrams per liter at the spring. By the way, it was nearly the same concentration at the cascade. I am happy you're all sitting. I'm happy to report there is sulfur in Sulphur Spring. I'm sure the Chamber of Commerce is delighted as well. So, oddly enough, the interpretation of that report puzzled me because both of those analytical reports from Montana indicated the presence of sulfate. And all sulfate is a sulfur atom with 4 oxygen atoms. So I just found it odd that even if elemental sulfur was not in there, certainly sulfate was, as was total sulfides, including that familiar H2S smell, hydrogen sulfide. As such, I am delighted to confirm that Meriwether Lewis's supposition that the spring was strongly impregnated with sulfur was accurate. By the way, there was also iron in that analysis. So he was correct about that also. Now, I would direct the audience to the work of David J. Peck, the author of Or Perish in the Attempt, to assess whether the mineral content of this water helps Sacagawea. I'm not qualified to opine on that. I do have an opinion as a non-medical professional that I don't think it was so much the commencement of this sulfur treatment as the cessation of the bloodletting and the purgative treatments that she was receiving that allowed her system to recover. But before leaving Sulphur Springs, Lewis noted that the buffalo are in immense numbers. They've been constantly coming down in large herds to water opposite us, because he's at Portage Creek, for some hours. They appear to make great use of the mineral water. This observation also turns out to be correct because it's been revealed with modern research that bison, just like cattle, require the consumption of sulfur. It's an essential nutrient for the normal growth of their bacteria in the rumen, and that's the bacteria that metabolizes amino acids and vitamins. So well done, Captain Lewis. And lastly, I'd like to conclude with discussing the captain's observations of Giant Springs. It's a remarkable hydrogeological feature. It's only half a mile from this auditorium. grateful when I visit the springs because it's only a mile and a quarter upstream of the Rainbow Dam, so I'm very grateful that it was not lost in that dam construction. Now, coming upon Giant Springs on June 18, 1805, Clark noted it was the largest fountain or spring I ever saw. The water boils up from under the rocks near the edge of the river and immediately falls into the river 8 feet and keeps its color for a half a mile, which is immensely clear and of a bluish cast. Even this is not some offhanded comment by William Clark. I reviewed 10 aerial photographs taken between 1995 and last year to ascertain the relative turbidity of the Missouri River and the water discharging from Giant Springs. Those photographs reveal that the crystalline water flowing out of Giant Springs remains segregated for at least 0.6 miles downstream, proving again that Clark's offhanded half-mile comment was accurate, especially given his method of distance measurements. This is the beauty of the journals, is the simplest thing that you look at. When you can confirm that, it's just riveting. Now, Lewis visited this spring a little later, on June 29, 1805. He noted, the water of this fountain is extremely transparent and cold. The water of this fountain boil up with such force near its center that its surface in that part seems higher than the surrounding earth. This is a keen observation from Lewis because it clearly indicates that the spring water is under hydraulic pressure. Now, researchers have determined that Giant Springs is a discharge outlet. It's not the only one. For groundwater that is migrated through the Madison Group aquifer from the Little Belt Mountains about 25 to 30 miles south and south-southeast. So envision exceptionally large amounts of surface water and snowmelt and rain infiltrating the rock and beginning a journey by gravity to Great Falls. When the groundwater in the Madison aquifer reaches the vicinity of the Great Falls, it flows upwards through hundreds of feet of rock and the overlying Kootenai Formation to discharge at the surface. You can see those closely spaced joints here in this orange-red outcropping of the Kootenai Formation. Lewis described the waters as flowing over some steep and irregular rocks in its passage to the river, which adds not a little to its beauty. Now, there's been a wide range of estimates about how much water is coming out, and that is partially dependent on when you measure it. If you measure it in the spring, that's when recharge is greater because there's melting snow, there's rainstorms, it's charging the aquifer, there's less recharge in winter. So the estimates are really wide. The low estimate is 156 million gallons a day. The high estimate is 388.8 million gallons a day, which is an astonishing 270,000 gallons a minute. Now, that's a number that's hard to grasp. So to help you visualize this, such a discharge could fill an Olympic-sized swimming pool, and those pools are 165 feet long, 82 feet wide, at least 6.5 feet deep. It could fill that pool in just 2.5 minutes. My last slide about Great Falls is about the age of the water. It's often called fossil water. It's a lovely phrase. And since the mid-1970s, it was thought that the age of the water discharging from Giant Springs was not less than 2,900 years old, nor greater than 6,300. However, I explore in the book why the radiocarbon analysis of this estimate is flawed. It's wrong. In short, for today's presentation, I can tell you that the modern radioactive isotope of hydrogen, called tritium, which was produced by nuclear fission in the atmosphere for above-ground nuclear testing in the 50s and 60s, and the modern chemical compound fluorocarbon, which was developed to be part of Freon for refrigeration, both of these are in the water at Giant Springs, not in some concentration to worry about. But it proves that the very presence and concentrations of these modern substances have suggested an apparent age of 24 years. Still, I think that's kind of amazing. So let me describe how this was derived. For example, if we took this whole group out after Norman's dog, and we went to Giant Springs and we collected a sample, And if that result came back with those concentrations of CFCs and this concentration of tritium, we would determine on this time series graph that these concentrations existed in the atmosphere in the year 2002. That would represent the date that water entered the aquifer at the Little Belt Mountains and began its journey to Giant Springs. Now, the calculation is more complicated than that. These compounds degrade in the atmosphere. They also degrade in groundwater. However, that is the general principle of this rather accurate age dating of the water emanating from Giant Springs. Now, as I bring my presentation and also the book to its conclusion, it's worth reviewing how I started this research in the 1990s. I asked myself what I thought was a simple question: how much geology and mineralogy is in the journals? Now, I came to find out after 2 years of putting together a spreadsheet that figuring out the number of plants and animals that the captains described is fairly straightforward. But a careful appraisal is required about geology because you don't want to double or triple count the same observation that's been copied between journals. So it turns out, I'm happy to report that there was a lot of geology to account for. On the outbound journey, when the expedition left St. Louis on May 14, 1804, to their arrival at Fort Clatsop on December 7, 1805, the expedition was on the move, meaning they weren't camped out somewhere, for 309 days. My evaluation of the original journals indicate that the captains made a geological observation in 45% of their everyday journal entries. Field journals, the field notes, not the polished journals. And that included everything from the occurrence of chert in Missouri, which they called flint, to differential erosion at the White Cliffs. Now, if you add in all the sedimentological observations, which is a branch of geology, the percentage of the captain's remarks is 60%. And this included detailed notations about overbank flooding and the formation of sandbars. I think this is a remarkably complete and continuous account of the geological terrain of the expedition, which I think has been generally overlooked. Moreover, it has been stated by some scholars, not all, that the original journals, in some instances, in Biddle's history in its entirety, had a dearth of scientific substance, but more specifically, no geological descriptions, and that it lacks scientific data that could have been used by early American scientists. Jefferson's also been criticized for not sending a scientist, although that person actually didn't exist at the time. In the concluding chapters of my book, I challenge this position by conducting a careful comparison of the geological remarks in the journals versus the rephrased observations in Biddle's history, and it revealed something startling to me. The very unspecific nature of Lewis and Clark's geological observations, unlike their exacting morphological descriptions of plants and animals, allowed their earth science notations to pass through what I call the scientific filter of Nicholas Biddle in the 1814 published account. In this representative example, the same details from the captain's journals are contained in Biddle's rephrasing, including the same listing of the rocks in this glacial drift deposit. I believe that paradoxically, the lack of mineral chemical analysis and the lack of dense scientific jargon allowed Biddle to use Lewis and Clark's geological observations as like scene-setting features in the day-to-day travel narrative. That's the hallmark of Biddle's history. But you might just well ask me, John, it's gratifying, I suppose, that the captain's geological observations made it into publication in 1814, but honestly, did it matter? I mean, unless some 19th century geologist or naturalist used it in some fashion, it would have no intrinsic value to the growth of scientific inquiry in this country. So the next and last avenue of research I pursued was whether or not the geological information in Biddle's history was used by 19th century geologists in the essential work of mapping the geology of the United States. I dedicate an entire chapter in the book to this, but I'm only going to give you one example of the value that a geologist placed in Biddle's history. This is Ferdinand Vanderveer Hayden. He was a trailblazing American geologist and director of the U.S. Geological Survey of the Territories. which covered Nebraska, Colorado, Idaho, Wyoming, and Montana. Hayden revisits the same terrain that the captains do, but he does it 50 years later. He leads expeditions in 1853, 54, 55, 56, and 1857 to 60. And then in his numerous survey reports, he praises Lewis and Clark's geological observations, stating in this 1863 report, the first reliable account of the upper Missouri country was attained by those enterprising travelers, Captains Lewis and Clark, and published in their excellent journal, by which he means Biddle's History. Hayden was clearly familiar with the captain's geological notations because he specifically refers to in the North Dakota observations of lignite, and then here in the Missouri Breaks region, he reports Lewis and Clark in their interesting account of an expedition to the sources of the Missouri gave a brief but accurate description of the physical features of this remarkable region, and he mentions that they provided superb detail on the picturesque portions near the stone walls, the region that we know today as the White Cliffs. In his final report, Hayden is far more effusive in his praise of the captains. He publishes in the Transactions of the American Philosophical Society, and then in an official government report several years later. I'm going to highlight for you on this slide some, but not all, of his remarks, because I think they merit an extended quotation. I do not wish to pass by the valuable layers of those frontiermen who were not as well prepared to develop the continuous geological structure over large areas. The first reliable explorers who added anything of value to the scientific knowledge of the Upper Missouri District were those enterprising travelers, Lewis and Clark. Considering the period when this expedition was undertaken and the grand results brought out by their report, it may justly be regarded as the first scientific expedition ever made on this continent. The description portion of their journal is excellent, almost unsurpassed for its beauty and accuracy. They gave so accurate descriptions of the general features of the bluffs, the coal beds, the different stratas of sand, sandstones, and clays, and etc., that their report has proved to be an excellent guide to subsequent explorers. This is Biddle's History. So from such praise and evidence that I present in the book, I make the argument that Lewis and Clark's expedition should be considered the forerunner of the four great federal geological surveys of the West that were conducted in the second half of the 19th century by Hayden, John Wesley Powell, Clarence King, and Lieutenant George Wheeler. This is exactly the design of Thomas Jefferson. He wrote in 1806, "These expeditions are so laborious and hazardous. They are headed, therefore, by persons qualified expressly to give the geography of the rivers with perfect accuracy, of good common knowledge and observation in the animal, vegetable, and mineral departments. When the route shall be once open and known, scientific men will undertake and verify and class its subjects." This is exactly what happened. And this is why I believe the Lewis and Clark expedition fulfilled Jefferson's enlightenment vision and was a resounding scientific success. So I hope you enjoyed the presentation. I thank you for your attendance, and I'll be happy to take any questions if we have time. Yes.
When you talked about the glacial dam breaking and changing, is that related to the scablands in Lake Bonneville up there?
Fantastic question. It was during the same time period. The question was Glacial Lake Great Falls in any way related to the more famous Glacial Lake Missoula? The answer is yes. They were not hydrogeologically connected. However, they formed at the same time, and they also released water in approximately the same time. There's more releases, over 110 releases from Glacial Lake Missoula. There's only been a documented 5 releases from Glacial Lake Great Falls, but it was during the same time period and the same climate drivers caused both incidences. Thank you. Yes, Jerry.
I realize that there's differences in scope and scale, but did you ever compare Clark's description of the Great Falls with the Great Falls of the Columbia?
I do talk about that in the book. He also made some rather vigorous and accurate height measurements of that as well. So 3 of the chapters are in the book, as I was telling David and Kenny, are based just on the Snake and Columbia rivers because, as David has pointed out, that's an underappreciated segment of the expedition, not by me. I felt like their observations along those 2 waterways was spectacular. Yes?
What is the elevation difference of the river above the falls to below the falls?
You know, estimates vary. I've seen estimates as low as 300 feet and estimates as high as 500 feet. But it's clearly more than a 300-foot drop. If you take just Great Falls alone, that's 87 feet. You know, Rainbow Falls is 47, so it's a couple hundred feet for sure. Any other questions?